In the previous lesson, we looked at the basics of hypothesis testing. Now we're going to do a hypothesis test. And for this section, we're going to be testing about the population mean. And in this one, we are going to know the standard deviation of the population. That's unlikely in the real world, but it gives us a chance to just learn the process. So there's two ways to do it, the critical value method and the p-value method. We're really going to be focusing on the p-value method. In a hypothesis test, the idea is to select a sample, calculate a statistic, such as the mean, and compare it to the value in the null hypothesis. If the difference between those values is large, it is less likely to be due to chance. And your null hypothesis is less likely to be true. Now, if there's really a small difference, the null hypothesis may be true. And we need to decide how strong that difference needs to be, how wide apart. So the College Board reported that the mean math SAT score in a recent year was 515 with a standard deviation of 116. Results of an earlier study suggested that coach students should have a mean SAT score of approximately 530. A teacher who runs an online coaching program thinks the students coached by his method have a higher mean score than this, meaning than the 530. Because the teacher believes that the mean score for his students is greater than 530, that's his claim, that the mean is greater than 530. Now, the earlier study had said that the mean is 530. Now, this other data that was given is from a sample. So that did not have anything to do with this claim. So we have to be kind of careful with what is known and what we're looking at. So suppose now that the teacher draws a random sample of 100 students to verify that this testing, this online coaching works. So they did the online coaching program. And after the program, those 100 students had a sample mean of 562. Now, this is higher than that null hypothesis of 530, but is it strong enough? Is it really high enough? So let's look at a test statistic, which is going to be our z-score. Now, assuming that we already knew the population standard deviation was 116, we can calculate the test statistic of our sample mean. We're going to take our sample mean minus the hypothesized mean divided by the standard deviation. Now for this, the standard deviation would be our population standard deviation divided by the square root of our sample size. And we get a z-score from this. Remember, a z-score is telling me how many standard deviations I am from the mean, from that hypothesized value. So I'm going to do 562 minus 530 divided by 116 divided by the square root of 100. And I get 2.759. That's 2.7 standard deviations away. If we think about when we draw a map here, so 530 would be in the middle. That's the one we're hypothesized about. And then 1 standard deviation, 2, 3. We are almost right here. That's 2.759 standard deviations away. Is that enough evidence? Well, we're going to figure that out. We're going to use what is called a p-value to see if it's far enough away. Now, before we can run this, we need to make sure that our assumptions when we're doing a test about a mean are satisfied. The first one is we want a simple random sample. And the second thing is we either need to know that we're normally distributed, or the sample size needs to be large enough. N needs to be bigger than 30. Those are our assumptions. Now, a p-value. A small p-value, that should not say that. A small p-value is considered an unusual event. The smaller the p-value, the more likely we are to reject the null hypothesis. But how small is going to be small enough? The level of significance is a value that is the borderline between when a p-value is small enough to choose the alternate hypothesis and when it is not small enough. So this level of significance is chosen by the researcher before we even begin the study. And it's what we're going to compare to. So if our p-value is less than that, we are going to reject the null hypothesis. If the p-value is greater, we will fail to reject. And we use the phrase statistically significant to describe the results when we decide that that p-value is small enough. So suppose that we have a p-value of 0.0122. And we are going to be comparing that to a level of significance, alpha, at 0.05. So 0.0122, 0.0122 is less than 0.05. So we reject the null hypothesis. Now, if we look at that for a 0.01 level, 0.0122 is actually bigger than 0.01, so we would fail to reject. Now, before we had technology, the calculating this p-value is actually really hard. So we used what's called a rejection region, which would mean that we would have found the area out here and compared that. And the smaller that area out here is, the more likely we are to reject. The p-value method really does make it a lot easier. So remember that we have two possible conclusions. We reject the null hypothesis or we fail to reject. We never accept the null hypothesis. We already assumed it was true. Court case, a defendant is assumed innocent until proven guilty. The defendant is never declared innocent. Consider again the example with the online coaching program. The null hypothesis was that the mean math score equaled 530, and the alternate was that the mean was greater than 530. Now we have 100 students that are randomly sampled, check. And they didn't tell us it was a normal distribution, but N is 100, so it is large enough. Now finding the test statistic and the p-value, we're not really going to be dealing with the rejection region right now. We're going to actually do all this in the calculator. So I'm going to go to my home screen. And we're still performing an inference, but this time it's a significance test. And we are talking about one mean. Now, the t-test is the one you use if all you know is your sample data. The z-test is if you know the standard deviation of the population, which we do. The population standard deviation is 116. So we have 100 students, a sample mean score of 562, and a population standard deviation is known. Now, the null hypothesis is that we equal 530. And notice that it's giving me an option. It has a box around that. When I click OK, I can either have less than, not equal to, or greater than. We want greater than. The sample mean was given to me. The sample size was given to me. The population standard deviation was given to me. And we are going to use a significance level of 0.05. If it's not given, we use 0.05. Now, on the next screen, it gives me my test statistic, that z-score that we found earlier. And it also gives me my p-value. Now, we want to decide whether that result is statistically significant. We are comparing it to that alpha. So alpha was 0.05. When I compare that p-value to 0.05, the p-value is less than 0.05. So we reject the null. Report that in context. So what does that mean? That means we conclude that the mean math score is greater than 530. Which again, remember that the mean score 562 was pretty far out there. 2.759 is really far out there. It is strong enough. And I'll go ahead and show you another thing that the calculator will do. So we got the z-score, we got the p-value, and it's easy to compare, but what if I forgot? If I go to the next screen, it says the null can be rejected because the p-value is less than alpha. Awesome. The American Automobile Association reported that the mean price of a gallon of regular grade gasoline in the city of Los Angeles was 2.82. A recently taken simple random sample of 50 gas stations, N is 50, had an average price of 2.77. Assume the standard deviation of prices is 0.15. An economist is interested in determining whether the mean price is less than 2.82. That's my claim. So that ends up becoming my alternative hypothesis, is that the mean is less than 2.82. So that means my null is that it does equal 2.82. Let's verify our conditions. Did they say we had a random sample? Check. Is my sample size large enough? Yes. Okay. So my null hypothesis is, whoops. Oh, goodness. Is 2.82. We want a less than. And my mean was 2.77, sample size of 50, population standard deviation is 0.15. Oh, I need my alpha. Oh, cool, it gave it to me. Alpha is 0.05, cool. So I'm gonna go to next. It gives me my test statistic, negative 2.357. That's pretty far to the left. Is it far enough? Well, my p-value is 0.009. Let me think about where that is. Negative 2. So here's my mean. 1, 2, 3. It's like way over here. That looks like it's probably going to be small enough. Well, if I look at the 0.009, 0.009 is definitely less than 0.05, so we will reject the null. If I reject the null, then we conclude the alternative. We conclude that the mean price is less than 2.82. The next one is about a mean height of adult men in the US is 69.7 with a standard deviation of 3. This is giving me population information. So it's giving me the population standard deviation of 3. A sociologist believes that taller men may be more likely to be promoted. So the mean height of male business executives may be greater than the mean height of the entire male population. So their hypothesis is that the mean height is greater than the population mean height, 69.7. That means my null is that, no, it is 69.7. A simple random sample, check, of 100 men, N is 100, check, has a mean height of 69.9. Assume that the standard deviation is 3. We are also given that alpha is 0.05. Cool. Back up. The null hypothesis is that the mean is 69.7. Our alternative is that it's greater. Our mean was 69.9, population size 100, standard deviation of 3, and alpha is 0.05. Our test statistic this time is 0.667. Ooh. 0, 1, 2, 3. Mean 1, 2, 3. So this is right here. Ooh. That area looks like it's going to be pretty big. Let's look at the p-value. Ooh. That's actually the area of that. That is kind of big. It is bigger, way bigger than my alpha. So we fail to reject. Now, if I fail to reject the null, that means I do not have enough evidence. If we fail to reject the null, then there is not enough evidence to support the claim. And I'm going to word it that way this time, support the claim that the average, the mean height is greater than 69.7.